Okay, so today I'm going to go over ternary compounds. So ternary compounds are ionic compounds that have three or more elements. These contain what is called a polyatomic, and you have a list of the polyatomics on Google Classroom. These nearly always have oxygen in them, and like I said, these are ionic compounds, and you will never have to write names or write formulas for covalent compounds or molecular compounds that have three or more elements, just ionic. So this is just an example. Here we have sodium bonded to nitrate ion, which is a polyatomic, and this is sodium nitrate. So a polyatomic ion is a group of atoms that stay together and have a charge. This is a list of polyatomics, and you have a list similar to this in classroom. What I highlighted on here are the polyatomics that you're going to be using most frequently, and these are the ones you're going to become very familiar with. These other ones you will also use, you just won't see them as often. And this is, again, just a list. But like I said, you have these on Google Classroom, but these are the ones you're going to be using the most. So when you're writing formulas for compounds that have polyatomics in it, you are still going to use the crisscross method to write your formulas. But here, what I want you to notice is that since I have more than one of my polyatomic, I'm actually going to use parentheses around it. Because if I didn't, it would look like I had 3 magnesium atoms. I would have like 1 phosphorus atom and 42 oxygen. That's not the case. There's actually 2 of these phosphate groups bonded to 3 of those magnesium ions. So let me actually show you this in another way for you to see this, understand why we use the parentheses. Here we would say we have a magnesium ion and another magnesium ion, but we'd have a phosphate ion in between, another magnesium ion, another phosphate ion in between, and another magnesium ion. So if you look at this, we have 3 magnesium ions, and then we have 2 phosphate atoms, and we actually have 8 oxygen atoms in that structure. Okay, when you're naming polyatomics, the polyatomics name is never going to change. If you have a positive polyatomic, like ammonium, and a nonmetal, you still change the ending of the nonmetal to IDE. Okay, so let's practice with the worksheet that's on Google Classroom. So on the left-hand side, you're writing the formula. So with the metals on these, you're going to be using the charge from your periodic table. So here we have sodium. So sodium has a +1 charge. And then we have acetate. So that's going to be C2H3O2, has a -1 charge. We're going to do the crisscross, but you notice here we have 1 of each. So since we only have 1 polyatomic, we're not going to need parentheses. So we're just going to do Na2C2H3O2. With the next one, we have magnesium with a +2 charge. We have carbonate with a -2 charge. We do the crisscross, we get Mg2CO3 2. That simplifies since they're both 2's, and that becomes MgCO3. Okay, down here we have ammonium chlorate. So ammonium, remember, is your 1 positive polyatomic, NH4+. Chlorate is ClO3-. Here we do the crisscross. We only have one of each, so we write NH4ClO3. Next one's a little tricky for students because there's peroxide. So in hydrogen, when it's first, we use the +1 charge. If hydrogen were second, we would use the -1 charge. Peroxide is O2 2-, that's a polyatomic. So we do the crisscross and we write H2O2. And we do not simplify this since peroxide had the 2 when we started. So we never get rid of a subscript that came with the polyatomic. And with this one, with iron 3 sulfate, we use that as our charge, just like we did on the previous sheet. This one's going to require a parentheses, so we would write Fe2SO3 3. Okay, on the other side of the sheet, we're going to write the name of our metal. The metal's name is going to stay the same. This is actually peroxide. If it were lithium oxide, it would be Li2O. You notice this is Li2O2, so that's telling us that's peroxide with that charge of -2. If we go down here, you notice here we have iron. To figure this out, we notice phosphate here is -3 charge. There's 2 of them. We have 3 of the irons. So 3 times X. For this to be true, for this to all equal 0, X would have to equal to 2. So it tells us we have iron 2 phosphate. So guys, I want you to finish this sheet and see how you're doing. Just get some practice and let me know if you have any questions.